Hello and welcome to another tutorial. So this time we're again going to be taking a look at design patterns, and we're going to be taking a look at two design patterns that I use quite a bit and that actually dovetail really nicely together. One is what's known as the command pattern, and the other is what's known as the command processor pattern. So not surprising that they work well together given the fact of similar names. So let's dive on in so we can start to get things set up. So the idea behind a command pattern is that it's a way that we can wrap up a activity, a set of actions into a containing object, and we can provide a consistent interface for what that sort of containing object can do, which means we can easily add in new commands and the interface for actually processing this stuff remains the same. So this can be really handy for turn-based games in particular. That's something that your player actions could be set up as a command. And this can make things a bit easier from a point of view of doing replays, doing undos, stuff like that. It can make it a lot easier. So what I'm going to do to start off with is I am going to create a script here, and I am going to call this base command. And then what I'm going to do is I will set up, once Unity's compiled, another command. And this will be command, and we'll call this move. And then I'm going to set up here just a cube, and the cube is what we're going to have run the particular commands. So we'll set up, so we won't have an empty one there, we'll have a cube. So I want to be able to attach a bunch of commands to this that all sort of follow in a very similar manner. So because commands and the actual command processor thing work so closely together, I'm actually going to have the command processor existing from the beginning. And then what I will do is we'll attach the command processor onto the cube, and we're going to add in whole bunch of move commands. So multiple different move commands is the idea. We'll put 4 ones in to begin with. And because we don't really need to be focusing on the game view, I'll just move it down there. So let's set up our scripts. So the idea is a command has sort of a common interface to it. So I've set it up as a class, and I'll make it an abstract class because there's going to be some common functions that I want to have in this. So the main one being is that I want to have a public abstract bool execute that will run whatever the particular logic is for the actual project. So for the command, let's open up our other files. So our move command, well, that has to inherit from base command, which straight away is going to mean that we get an error because we haven't implemented the abstract interface, which is fine. So that's good. So what we can then do is, we can set up variables for this. So our move command might take a vector 3, and we could call this move direction, or we could make this a velocity and it gets given a time. Either one would be reasonable. I'm going to go for move duration. So we can specify a direction, which will encompass a speed in that, and then we could specify the duration that it moves at that. So then when it executes, well, we can now actually look at how we want to set up our command logic here. So we've got a few different ways. So this could be something where it would be handy for the base command itself to actually probably take some of that logic for execution in terms of, is this something that runs over in multiple sort of frames? So what I could do is I could actually make this execute internal, and it becomes protected. So this switches to being protected, and there's an execute internal. Then we can set up a bool here. Public bool is executing. Make it so that it's only able to be set internally. Then I could set up here a function execute, and what we do is we set is executing to true. Then I can actually run our execute function. So I could go and say, okay, well, fexecute internal. So we could use it so that it returns a Boolean to indicate whether it's done. But that could be something where it gets a little bit, there might be variations of what we want to indicate there. We might want to indicate success, failure, in progress. So I'm actually going to have here command result, success, failed, success, failure, in progress. So then these can now return that. So then what we do is here, okay, well, f execute internal, f that gives us back our in progress one, then we just return in progress because we're still going and doing the executing. Otherwise, we would actually need to return true or false. So we know we're no longer executing in this scenario, but we need to store that result. So I'd actually do this, which will simplify our logic even further. So we could return result here. We could return a result here. We just need to check like that. The other thing we could do is if we flip this logic around, we can actually make it a little bit cleaner. So if it's not in progress, we turn off executing. Otherwise, we can then just return the result. So that will give us the execute side of things. That then also means we need the update function. So we'd need a protected void update. So f is executing. Then we could actually just rerun this function. So it means that we can actually each time tick that execution ahead one step. So that looks pretty good. What that would mean is for the move, we can have float move progress is 0. This can return the command result. So we would advance the move progress first. Time delta time divided by move duration. And then what we would do is transform, and we could do a transform translate. And what we are translating by is the move velocity multiplied by our time delta time. And then what we return is, and this is where we use the move progress, is if move progress is greater than or equal to 1, then we return success, otherwise in progress, and we use the failure state as a safety check here. So if our move duration is equal to 0, and actually if it is less than or equal to 0, because if it was less than 0, it would then make this progressively more negative, which would be incorrect. So if it's invalid, we can return failure. So that's a little command all set up. So, okay, we'll then set up our command processor. So this can have here a base command list, or commands, I think will be fine. So we'll do commands equals get components, and what we do is we get the base command 1 that'll find all of the ones on this particular class of that type. Then in update, well, what we need to do is our processor needs to know which command we are up to. So int current command, and if we say start that at 0, then okay, what we would do is if current command is greater than or equal to commands.length, we do nothing. So because we've already, that would mean that we have completely exhausted all of the commands, so we stop trying to run anything. Otherwise, well, what we could do is our current command, we access that one. So we go execute, and we store the result. If that result is equal to success, then we advance the command. If that result is failure, then this would be down to what do we want our failure behavior to be. But for now, I'm going to say that the failure behavior is we stop executing commands. So this will go through, it'll execute that command. So now what I can do is I can set these commands up, and we should be able to just run, and it will actually do those. So we're going to say 2 seconds for each of these. First one, we will move it in X, then in Y, then in Z, and then back to the start. So let's test this out. Should see our cube move in a succession of steps. So here's our first move, and traces back to the beginning. So we've got basic command going there and a basic command processor, which is excellent. So now let's properly take advantage of the fact that we've got these commands, and let's set up a few more commands and some more useful interfaces to this. So we're going to add in a rotate command. So this will inherit off of base command. Get rid of these, and same as before, we'll implement that abstract class. We set up our logic here in terms of rotation. So we'll have our rotation rate. And then we have our float duration. We can make sure we match similar, so we'll call this rotation duration. And it's going to be quite similar to what we did for our move command here. We'll have progress, and I'm actually just going to bring this across because they are quite similar. So rotation duration, like that. We'll go for referring to this as just progress, and I think that's something where I would actually update the move one here, make the naming a little bit more generic. So our setup here, divide by rotation duration, rather than a translate, we do a transform rotate. We give it our rotation rate, and the so that gives us, with this, we can just give it the Euler angles, and we multiply that again by time delta time. So now we've got a rotate command. The other things we could do that could be useful for the commands is giving them a cleanup and a setup functions. So we could have here one that is a protected abstract void, prepare to execute, internal, and we could also then have a cleanup one. So protected abstract void, and this one would be what we would call this is cleanup after execution, internal. Now these, not everything would necessarily need these, so I might actually mark these as they can be virtual rather than abstract. I'll still keep them as protected, but I'll make the body of these largely do nothing. And then up here, I have the actual public interface, prepare to execute, and that will call the internal one. So this strategy of having public but non-virtual base class members and them calling a virtual protected member is a pattern that I tend to like to follow a lot, in terms of it ensures that I have very clean interfaces, but it also means that if at a later point I needed to inject a bit of logic before or after a command actually does its execution or does any of these functions, I can do that with just changes in one location. I don't need to go and potentially modify a lot of existing code. So I find it's really just a time saver for sort of future changes. And I've had to do that enough times where I find it tends to keep things neater, cleaner, makes things easier to update in the future. So similarly, our command processor, well, it's gone to pick a command to execute. So there's a few sort of improvements I could make to this. One, I'm going to rename this to current command index, so that what I can do is I can have base command, current command, and what this will do is, if current command index is a greater than or equal to 0, and current command index is less than commands dot length, then we give back commands at current command index, otherwise null. Now that line ends up being a little bit lengthy, so what I would potentially do is actually take this and have a bool is command index valid, like that. so that I can then do that check here. So it keeps the lines not getting ridiculously long so that you have to scroll to read them, which is always a bit of a pain. And what that means is I also then have helpers down here where I can just say, well, F, there's no command index valid. Then I return. This becomes current command. And what I can also do is I can then, well, F current command is not executing. Then I say current command, prepare to execute. And then here, where I advance that command index, I can say F is command index valid. Then if it is, actually, no, I wouldn't do it that way, sorry, because this is the closeout. So I would say current command, clean up after execution. So we've got a bit of a cleaner life cycle happening there. I would also, just because we might want to use this in other cases, I would actually have a process commands function that I bring all of this into. I usually try and avoid update getting to be sort of too lengthy. I think it's better just to have it be fairly minimal and then put that logic into other functions. So, okay, we've got our prepare to execute, we've got our execute and our cleanup functions, we've got our failure behavior happening, so it's good. What we can now do is let's link up a few of those new commands that we added in. So what I will do is at this point, let's have it rotate about 2 of the axes. Now, because how we're rotating this, there's a chance we could get gimbal lock, probably not, but it will find out. So it should move, and before it does the final move back, it should rotate, which it does for a few seconds, and then attempts to move back, but because it's ended up moved in a different location, it's obviously not going to move back to the exact spot, which is kind of what we should expect with it doing a bunch of rotations in there. So that's good. We've added in a bunch of commands there, and we've seen, it's very easy to set that up with the command processor, which is cool. And, with this, we manually added these onto here, but we could also be doing this via user interface. So this is our cube 1, but let's add in a sphere, and we're going to leave the sphere in the exact same spot. We'll give it a command processor, but then I'm going to set up some very basic UI. So the UI is going to have a few buttons and everything, but we'll get this set up first. So we want to scale the screen size. That resolution looks fine. Anchor this down the bottom. And I'm just going to set up a few different buttons. So these buttons can map to the particular commands. So we might have move +X, and we'll just set the text here, move +X. We'll have a -X, +Y, -Y. So I have the full set of ones here. And so this will make it really easy for us being able to execute the logic. And this would also be something where, like, we're having it that it's fixed. the particular command buttons that are here, but you could also have it that what buttons are shown are based upon the commands that are available. We could even have it that the commands that are available change based upon the object that is selected. And then our processor doesn't really care, because the nice thing is our processor doesn't need to know about the internals of how a command works. All the processor needs to know is here is the interface, and that's sort of the key thing with it. So we add in our layout group, we'll let it expand in height like that, and we'll set a little bit of padding. That looks good. And then we'll set up a little helper script that will map these buttons. So we can go here. So our command UI. So we'll set that on here, and then through the UI we'll be able to issue different commands. So what we would have is it's going to need to know the target processor, and then it's going to need a whole bunch of different interfaces here. Now, this is something where, again, we could have some more generic configuration stuff where it's a case of each button you can select the particular command class from a drop-down. So if you wanted to do a whole bunch of editor extensions, we could do something like of that. For now, I'm just going to have an on command and positive X, I call it pos X. So with that function set up, I need to have it enqueue the command. So I want the target processor to ideally be able to, we do something like this, where we can say enqueue command. And I would want to be able to do something like, okay, well, a new move command. Now, the challenge with this is we would be newing a mono behavior, which is something that will technically run, but you will get warnings for it, and it is inadvisable. So, and a mono behavior, we can't just instantiate one without attaching it to an object. So we've kind of got two options. We can either attach this to a target object, or what we can do is we can actually change it to a scriptable object, but that would change what we're able to do with it. So I think in this case, adding it onto the target processor probably makes the most sense. So I can go target processor, and I need to get the game object. Then I can do an add component, command move. Now, add component does return that new move command. So new command. So I can pass that here, because I need to be able to say, well, new command, configure, and we give it a new vector 3. We'll say 3 in X, nothing in any of the other axes, and a duration of 3 seconds. So these are the interfaces I want. So I'll set up for the negative. And then I will also set up the ones for our other axes. So Z, we have Y, and we need to make sure we update the values that get moved here. So if you did never need to attach it to a particular object, then we could switch it to being a scriptable object, would be perfectly viable. But because I want to keep it as something that I can attach, I'm not going to be doing that in this case. So enqueue command is one we need to be able to add support for. So we'll be able to get here and go public void enqueue command. And then we can say that that is a base command, new command. Now what I really want to be able to do is go commands, add, new command. But because it's an array, I can't. So I'm actually going to switch this over to being a list. That will make it so that I can go and easily adjust it, which will be good. Does mean I need to change down here so that this is a new list of base commands. And if I'm accessing commands, which I'm not, that changes to account. So now I can add commands in and they will just go to the end of the list, which makes sense. That's where we would want them to end up. And then our UI, I also need this configure function, which configure is going to be specific to the particular command. So this needs a public void configure vector3 velocity and a float duration. And we just set those across. Like of that. So that's something where the parameters are going to be different for each command. So we can make sure that it has a function called configure, but we can't keep it as being the exact same one. Now I can link this over. So all of these buttons, we add in a hook here. And I just need to go through and link up each of these. So we have positive x, then we have negative x, positive y, so it takes a little bit for hooking up all of the different ones, but it means that we then will be able to queue up a bunch of commands. And the handy thing with this is it will mean that while it's running, we can actually continue to queue up a command. So the sphere is doing nothing. Let's give it a move in X. So we got an error because we didn't tell it the one to be listening to. So there we go. Link that up. So the sphere is moving. So let's tell it to move in -x, and then we queue up another one. So we can run multiple commands all in one go. So I can just tick all of these, and it's just going to run that sequence. So it now means that if I was, say, in an RTS or something like that, and issuing a chain of orders to units, I could do this. It just adds them onto their own queues. So you could have, this could be for like a building where you can build multiple things, or you can give an AI multiple waypoints and that to be heading through. Each one could be a separate command that it's actually performing. So it gives us a really flexible setup for being able to create something that is very easy for us to expand. Adding in new commands takes very little time, has very little logic, and it will just work, which is great. So I use stuff like the command pattern and the command processor pattern quite a lot. So we've used it in things like Heave for every bit of the user input there. I've used it myself in things like drawing programs. So making a drawing program and each brush stroke, each changing of the brush, things like of that were separate commands. So it just makes the setup of those things much easier, because if you want to undo, you've got a self-contained thing that knows, here's what I am trying to do, and can also, because we've got our start and end functions there now, can know, okay, well, here's what I did, here's what the changes actually were, and could undo those if need be. which is super valuable. So dive on in and experiment with this, see where there might be things in projects you're working on where you could apply this. It's really, really valuable pattern, and I do recommend making good use of it. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and I've placed a link to that in the description below. If you have any questions, chuck in a comment. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time, bye.